Good evening, 8th grade, and this is your Unit 3 test review. So, question 1 here says, use the diagram below to answer the following questions. So A says dilate OPQ from center O and scale factor R equals 1/3. Label the image OPQ. OP prime, Q prime. So there's two different ways to work out this problem. So the first way, and probably the easiest way, would be to do something we touched on briefly. And it seems like most of you forgot this as it was a while back. So we can figure out how many units we have. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 units from O to P. And then I'm going to multiply that times 1/3, which equals 3. So then I now have 1, 2, 3. So that is P prime. And then I can do the same thing for P and Q. So PQ is 1, 2, 3, 4, 5 units. And I can multiply that times 1/3, which is 5/3, or 1 2/3. So I can go up 1 2/3, and that's Q prime. The way that most of you seem to be doing it, which is what we spend a lot of time focusing on in class, was finding the points, multiplying those by 1/3, and then your image is going to be down here. So O is at 2, 2. P is at 11, 2. And Q is at 11, 7. So then if I multiply everything by 1/3, this becomes 2/3, 2/3, and that is O prime. And then P prime is going to be 11/3, 2/3. Which is 3 2/3, 2/3. And then Q prime is going to be that 11/3 again, and 7/3, or 3 2/3. And 2 1/3. So from there, I can plot those points. So I have 2/3. So you can kind of estimate. So I have 2/3, which is right about here, and 2/3, which is right about here. So this then is O prime. And then P prime is going to be at 3 2/3. So we're going to go over to 3 and a little bit more. And then we're going to go up to that same 2/3, which is right about there. There's my P prime. And then Q prime is at this same 3 2/3. And then up 1, 2, and 1/3. It's Q prime. And then I'm just going to connect those. And you still have the same image regardless. Okay, so if we're finding the coordinates of P prime, Q prime, that is going to be dependent on which method you used. So we will call this method 1, and we will call this method 2. So for method 1, P prime was at 5, 2. Q prime is at 5, 4 2/3. For method 2, P prime is right here at 3 2/3, 2/3, and Q prime is right up here, 3 2/3, 2 1/3. Either of those answers would be completely acceptable. All right, C, are angle OPQ and OQ prime P prime equal in measure? So we're looking at OPQ right here and OQP. That might be a typo. Yep, that is a typo. That should be P prime, Q prime. Sorry about that. So are these equal in measure? Yes, they are. Because due to the theorem on similar triangles, I have the same angles, same interior angles. Okay. Then D, what is the relationship between the segment PQ and P prime Q prime, and explain in terms of similar triangles? So we're looking at PQ and P prime Q prime. So it's going to be easier if you have this green line opposed to this. However, because they are a dilation, you're still going to get the same answer. So what you would write here is PQ is similar to P prime Q prime. Therefore, hold on. Triangle OPQ is similar to triangle OP prime Q prime. Therefore, PQ is parallel to P prime Q prime. And again, it doesn't really matter because if you notice, these lines are parallel, therefore these lines are parallel and these lines are parallel. All right, E, if the length of segment OQ, so this one right here, is 9.8 units, what is the length of OQ prime? Explain in terms of similar triangles. So again, we can figure that out by taking 9.8 times our scale factor of 1/3. 9.8 times 1/3 is, biscuits. All right, let's try this a different way. All right, so I have 9 8/10 is 9 4/5 equals 49/5 times 1/3 is 49/15, which ends up being 3 4/15. Okay, so that would be this line segment here if we were told that OQ is 9.8. Okay, question 2. Use the diagram below to answer the questions that follow. The length of each segment is as follows. OX is 5 units, which is labeled. OY is 7 units, which is also labeled. XY is 3, again labeled. And X prime, Y prime is 12.6. So everything, all the information that's given is already listed for you. A, suppose segment XY is parallel to segment X prime, Y prime. Is OXY, triangle OXY, similar to triangle OX prime, Y prime? Explain. So Since they're telling us that these two lines are parallel, we can assume that they are similar. So yes, they are similar since dilated triangles create parallel lines, and I do believe that was on page 39 of your book. You can always follow up with that if you need to double check. All right, B, what is the length of OQ prime? Show your work. Sorry, OX prime. So we are trying to figure out how to get from here to here based on this. So what we need to do first is we need to figure out where we have the same information that we can figure out some sort of scale factor, or if you remember, we could put the missing length in, but we had to keep everything corresponding. So we can use this 5 and this 3, and then we're going to use this length here because these two lengths correspond, x, and then 12.6. So the sides, the information needs to stay the same. So if I'm doing this line right here, I have to do this line right here on the same side of my fraction. If I'm doing this line right here, I'm doing this line right here on the same side of my fraction. This triangle is on one side, and this triangle is on the other side. So this would be the gray triangle. This would be the white triangle. So all of the information for the white triangle is on one side, all of the information for the gray triangle is on the other side. Now all you have to do is multiply. So we're going to cross multiply. So I have 3 times x equals 5 times 12.6. which equals 63. And then I'm going to divide both of these, so x equals 21. So this whole length then is 21. Now I can do the same thing for OY. So instead of using this 5 here, because that's x, now I need this y piece. So I'm going to have 7 over 3 equals x over 12.6. And if you notice, my denominators are the same because I'm keeping those parts of the triangles the same. Again, this is the gray one, so I have all of the gray information together. Here's the white one. This is the OY, and this is XY. So I'm keeping all of these pieces together to make sure that I'm getting the right answer. Again, we're going to cross multiply. So I end up with 3x equals 7 times 12.6. That equals 88.2. I'm going to divide both sides by 3, and x equals 29.4. Let me just double check my math really quick. Yep, 29.4. All right, last page. All right, given triangle ABC is similar to A prime, B prime, C prime, and triangle ABC is similar to triangle A double prime, B double prime, C double prime in the diagram below. Answer parts A through C. Describe the sequence that shows similarity for triangle ABC and triangle A prime, B prime, C prime. So A prime, B prime, ABC is here. A prime, B prime, C prime is here. And A double prime, B double prime, C double prime is here. So here are the series of triangles. So to figure out how we get from here to here, we have to figure out our points. So A here is 1, 1. B is 2, 3. And C is 3, 3. Now, if I'm comparing that to A prime, B prime, C prime, I have -2, 2. B is at -4, 6. And C is at -6, 6. So I'm trying to figure out how I'm getting from these values to these values. So if I do a 1 times some value, I need to get -2. So 1 times a -2 is going to be -2. So I have, for my x, -2, and then 1 times 2 is 2. And I'm going to do the same thing with all of those. So then I have 2 times some value gives me -4, -2. 3 times some value gives me 6, that's 2. 3 times some value gives me a -6, -2. 3 times 6, 3 times some value is 6, that's also a 2. So my scale factor is 2. Because I'm enlarging it, it's always going to be positive. So since I know my scale factor is 2, that would actually create a triangle over here. But my triangle is this way. Since B and B are facing each other and C are farther apart, I have a reflection. So I have a scale factor of 2 and a reflection. That gets me from triangle 1 to triangle 2. Next, we're going to describe this sequence that shows a similarity for A, B, C to A double prime, B double prime, C double prime. So I'm just going to rewrite those points. And then we'll figure out what our X and Y's are. And then we have A double prime, B double prime, C double prime. So these points are roughly, A is going to be about 1/2, -1/2, 1/2. B is down here at -1 and 1 and 1/2. And then C is over here about -1 and 1/2, -1 and 1/2. So to get from 1 to a -1/2, I'm going to multiply by a -1/2. 1 times 1/2 is also 1/2. 2 times a -1 is a -1/2. 3 times some number gives me 1 and 1/2. That's 1/2. And then these 3's again, a -1/2, 1/2. So again, we can't have a negative dilation. Everything's going to be positive, so I have a dilation of 1/2. And then we're going to figure out how this works. So if I did a reflection, that would go here and then here, that wouldn't work. So this is actually a rotation of 180 degrees. All right. And last question, C. Is triangle A prime, B prime, C prime similar to A prime, A double prime, B double prime, C double prime? How do you know? And I can know that because even if we went from triangle, which is how the triangles work, go from 1 to 2 to 3, I should be able to get back from 3 to 1 easily. And we've proven that we can get from 1 to 3 quite easily. So yes, they are similar. Okay. One thing I would mention that's not on the test, but I'm hoping that you still remember it from last week, is the Pythagorean theorem. and I hope you feel comfortable with that as well. If you have any questions or you need any further help with the problems, please don't hesitate to reach out. Have a great evening. Bye.